Hello, my name is Beth Dixon, and this presentation is on confidence intervals on proportions and is presented by me, Beth Dixon, and is designed to be used as a supplement and does not replace your classroom instruction. Your classroom instruction, as always, is your best tool for your learning. Let's look at a confidence interval, and we're going to look at a confidence interval based on the popular movie Twilight. In April of 2010, there was a survey on Facebook about Twilight, and the fans on my Facebook were asked which hero they preferred, Edward Cullen or Jacob Black. And even if you do not know who those people were or are and don't understand it, we can still do this problem, and we're going to construct a 95% confidence interval on the proportion of Facebook Twilight fans that prefer Edward Cullen. Now notice that in the wording of the problem, we know that we're going to be doing a confidence interval because of these words. Construct a 95% confidence interval. That tells us we're going to be doing a confidence interval. We also know that we're going to be doing it on the proportion because of that word there. So we need some additional information, and I didn't put it here, but we know from my information that we are given that in our sample size was 339 people responded to this survey, and out of those 339 people, we had 197 of them respond that they preferred Edward. Now, there are some problems with this. First, it's not truly a random sample in the survey. These were people who wanted to respond to the survey. It's not truly a random population. These were a particular group of people on Facebook who had some commonality. They were mainly fans of the book to start out with, and mainly females, and since they were my friends, they were of a certain age and not necessarily a random age. The other problems that we have with this, we didn't know what the general population or the sample population size, the population size was, the big N size was. So those are problems and make it really impossible for us to do this problem. But it made it for an interesting problem to do, so we're going to ignore those facts and just do the problem anyway. So let's go on and do this problem. So let's start with 339 for our sample, with X being 197 people who preferred Edward. Our p-hat then is always given by X over N, the part divided by the whole. That's the proportion, which would be 197 divided by 339. And we just do that division, and that comes out to be 5.581. And that's step one, to gather that information and proceed from there. Step two is to figure out what Q-hat is. And to do that, that's 1 minus P. Now some teachers use the Q-hat and some teachers just leave it as 1 minus P. but that's going to be 1 minus 0.581, which is going to give me 0.419. Now, we need to see if this is Bell enough to do the problem. And there are a couple of ways that we can do this. One, which is the way the book does it, is N times P hat times Q hat, or N times P hat times 1 minus P hat. In either case, that would be 339 times 0.581 times 0.419. And just multiply those numbers out. And when you do that, that gives us 82.5, which is greater than or equal to 10. And this greater than or equal to 10 is a constant. It always must be greater than or equal to that 10. And if that's the case, then we meet the requirement that it's Bell enough. Or we can do N times P hat and N times Q hat, which would be 339 times 0.581 and 339 times 0.419. Doing both of those and calculating that out would give us 339 times 0.581 gives us 196.96, which must be greater than or equal to 5, which it is, and 339 times 0.419, which gives us 142.04, which is also greater than or equal to 5. Now, you don't need to do both of these. This is an OR. Some teachers use the top method, some teachers use the bottom method, and you will want to follow the method your teacher uses. And in addition, some teachers will also want you to make sure that your sample size is, less than 5% of your population size. And in this case, we have to do some assumption here that you wouldn't want to do in real life. In real life, we couldn't do this because we do not know what our population size of Facebook was of people who Twilight fans. So for our purposes, we'll just assume that our sample size is at least, our population size is at least 20,000, and 5% of 20,000 is 10,000, and then 339 is less than or equal to, that's 1,000. Can't count my zeros here. And so our requirements are met, and we can compute the data. Now, step 3. We want to compute the confidence interval, and we wanted to compute the 95% confidence interval. So that's going to put 95% in the center. That leaves our alpha at being 5%. Confidence intervals always divide up into two tails. And since the two tails are divided into two, 5% divided by 2 then leaves us 0.025. So that leaves us 0.25 in the left tail and 0.025 in the right tail. So we can use our table to look up 0.025, and that will give us a z-score that corresponds to having 0.025 to the left of 1.96. The next step is to compute the error. Now, some teachers will let you go on and compute the lower and upper bounds, but I like to compute the error separately. So that's going to be z, that corresponds to my alpha divided by 2, times the square root of p hat times 1 minus p hat over n. Or if your teacher's using the Q, that's z alpha sub 2 p hat q hat over n. Same formula, just some teachers use 1 minus p and other teachers use the Q. So the z, remember, was 1.96. The p hat, remember, was 0.581. The q was 0.419. And then the n was 339. Now, when you enter this in the calculator, when we write it, it's really handy to put these parentheses there. But if you put those parentheses and try to end the parentheses too soon in the calculator, it will make it a difficult procedure. The best effort that you can do is just to type it in and type in 1.96, then second, and then your square root button, which is above your x squared. That will automatically start a square root, as parentheses, on your calculator, and then just type in 0.581 times 0.419 divide 339, then put the end parentheses and then press your enter button. That is the best way to type that in, and that should give you your error, and that gives you 0.053. Now, different teachers have different rules about rounding, and you will need to follow those rules for your rounding. And now we're going to figure out our lower bound, which means to take what we started with, which is the p hat, 0.581, and add the error. For the lower bound, we'll subtract the error, 0.581 minus 0.053, and that gives me 0.528. And for the upper bound, we're going to take 0.581 and add 0.053, and that'll give me 0.634. Again, I've rounded to 3 decimal places and kept that consistent. Your teacher may have different rules for your rounding. Be sure to follow those. And our last step is to write our sentence. I can say with 95% confidence, and that's how you'll start out every conclusion. I can say with, and then fill in your percentage of confidence. That, then go back and look at what you're trying to say. You built a confidence interval on the proportion or in the mean. Well, that the proportion of, and then what am I talking about? And then just quote from the original problem. Facebook Twilight fans that prefer Edward Cullen to Jacob Black is between, because it's a confidence interval, so we're going to state the interval, and we take those two numbers we just got and change them to percents, because this is a proportion, between 52.8% and 63.4%. I hope this helps you figure out how to do your proportions. Thank you for watching. If you need additional help, please come and see us.